then you now scroll down. So this is where I computed using Excel. So on your Excel sheet, this is the GPS coordinate from ground surveys. All right, the GPS coordinate from ground surveys I obtained. This is serving as the reference data. All right, then here is the map coordinates, the digitized coordinates. So I imported this set of GCPs into the ArcMap environment, then I digitized it, okay, on the georeference imagery. Then I obtained this set of coordinates with respect to its equivalent ground control points. All right, ground coordinates. All right, so when I did the differencing, so the distance of this minus the distance of this will give you 0.26. the northings of this minus the northing of this will give you 0.4. so this is the X residuals, this is the Y residuals, and that is how everything is done for the 40 control points. So when you are done with that, you will now do the mean error. The mean error for the X variable is 0.04, for the Y variable is minus 0.01. then the variance is this. All right, the variance is this respectively for the X and for the Y. Then the standard deviation for the X, for the Y is this. Then the root mean square error is the sum square of the square root of the standard deviation, both for the X and Y variables. You are going to have this. So that is how the root mean square came about. So that therefore means that the satellite imagery, all right, the satellite imagery is plus minus 0.739 approximately accurate. That shows that the georeference Google Earth imagery is this accurate. Okay, it is this accurate. So that is the idea of the project. So if you scroll down, you are going to see where I did the map. So this is the map of map showing GPS coordinates, that is the GPS features spread over the georeference satellite imagery of the study area. So if I zoom now, you are going to see the points. So these are the points. All right, I imported GCP's points, so it's just spread across. So it's not compulsory, it is all the region of the study area, just sparsely distributed. All right, so these are the set of 40 points, the GCPs. Okay, so therefore I digitize the same features. Okay, I digitize the same features on the imagery, then extract the features. So the extracted coordinate is what you see here as the map coordinates. Okay, these are the map coordinates, okay, of that same GCPs. So if you scroll down beyond the map, you are going to see below here, this is the map showing the relative shift between ground surveyed perimeter to the equivalent digitized perimeter of a section of the study area. So what you are seeing here simply means that the red boundary line was a perimeter survey carried out by a set of researchers. All right, they carried it out with the total station traversing. So I extracted this perimeter from the AutoCAD drawing, then import it into the ArcGIS and overlaid it on the georeference Google Earth imagery. So this is the red reference perimeter survey, okay, with the ground method. All right, then this yellow boundary is the same features, okay, on ground. All right, but this is actually digitized from the satellite imagery. All right, that features is digitized from the satellite imagery, the yellow boundary line. This simply means that the yellow one is the georeference perimeter digitized, while the red one is the imported ground surveyed perimeter. So you can see the shift in between. Okay, you can see the shift in between. That shows that the satellite imagery cannot be used for cadastral surveys. That is the implication. When you download an imagery from Google Earth and you do reference with ground control point, then you digitize features from it, you cannot use it for cadastral surveys. You can't use it for that. Any information you have on a georeference imagery can only be used for mapping purposes, just for mapping purposes. You cannot use it for cadastral surveys. The standard of accuracy for cadastral surveys is less than or equals 1 centimeter, but the shift here is obviously, okay, more than 1 cm. Okay, it's obviously more than 1 cm, and the accuracy of this georeference imagery is plus minus 0.739. which is in meters. So you can see that it is much more than the 1 centimeter accuracy requirement for cadastral surveys, and that is the essence of this project. So we have shown the relative shift between the ground perimeter and the digitized perimeter. So that is the idea. So this is the AutoCAD drawing of the perimeter. So this is control extension of the perimeter with the total station, and here is the boundary of the perimeter of this study area. So this perimeter was overlaid, okay, on the georeference imagery, which is the red. All right, just like what I explained earlier. So you can see the shift up there. All right, so this one is just the residual chart, nothing much to explain there. And the conclusion of the matter is that it was discovered after analyzing the results that the absolute accuracy of the georeference imagery gave a root mean square of plus minus 0.739, approximately 0.739 meters root mean square error. Okay, so that is the conclusion of the matter. This is the accuracy of the satellite imagery. Then the standard requirement for accuracy for cadastral and engineering surveys is 1 cm for cadastral surveys, while for engineering surveys is 5 millimeters. So your georeference imagery cannot give you this. That shows that it is not good for cadastral and engineering surveys when you want to carry out engineering surveys and cadastral surveys. So but the satellite imagery is only good for digitization and other Reiki survey operations due to the accuracy that we obtained. So that is the idea of this project. So you can now recommend the following: that satellite imagery is only advisable to be used for GIS measurement purposes only, okay, and it is not good for cadastral measurement. So only the ground method of surveying meets the accuracy standard for cadastral measurement and engineering surveys. So that is the essence of the project. Thank you for watching. See you in the next video.